Hi all. In the last video, we have been discussing how to convert a ER diagram into relational schema. We have also seen a few university questions related to this topic. Today we can see one more example. So this is the question. So let us go through the question. The ER diagram given below. The names of the entity set and the relationship are shown in the capital letter. Okay, so this is a entity set. So entity set name is actually given in the capital letters. This is store is an entity set. City is another one. Item is another one. Orders is another one. Customer. Okay, so these are the entity types or entity sets, and below the names they have written something. These are the attributes. Usually attributes are written in elliptical or oval shaped in the oval shaped thing, but here they have written this attribute under the entity name or entity set. Okay, and these are the relationship: located, hold, in cities, item ordered, place, and these are the relationship. Okay, the relationship is also having certain attributes. This, for example, this hold is having a attribute, that is what written here. Quantity held, that is the attribute here. In cities is also having a attribute called quantity in cities. Items ordered is also having an attribute called quantity ordered. Okay, so these are the entity sets, their attributes and the relationship. Okay, then they have given the key attributes are underlined. Okay, the key attributes are underlined. So these are the key, primary key. Here the store ID is the primary key. Here city name and state is the primary key. Here customer name is the primary key. Here order number is the primary key. Item ID is the primary key here. Okay, all the participations are total. Okay, so here the participations are total. That means that usually the total participations are given in double lines. Okay, usually in ER diagram they will be given double lines, but instead they have in the question itself they have provided that theory, that concept, that is all participations are total. Okay, instead of giving the double line they have mentioned in the question. Okay, then you have used the standard synthesis procedure to convert ER diagram to corresponding relational schema. So you have to follow the synthesis procedure to convert the ER diagram to relational schema. Okay, you have to clearly show the primary key as well as the foreign key. Okay, so the first and the foremost thing we have to do is that we have to identify the entity sets. So the entity sets are store, cities, item, order, customer. These are the entity sets. Okay, so you can start creating the schema. So the first schema, stores. The store schema must have attributes like store ID, address, manager. Okay, so stores must have attributes like store ID, address, manager ID, and store ID is the key attribute. Okay, so that is why it is underlined. Clear? Next is city. City must contain three attributes: city name, state, headquarter address. City must have city name, state, headquarter address. Then item must have attributes like item ID, description, size, color. Item must have item ID, description, size, color. Okay, then orders must have order number, order date. Orders have order number, order date. Okay, then customer contains three attributes: customer name, address, phone number. Customer name, address, phone number. Okay, so all the entity schemas of the entity sets we have already drawn. Okay, now we will check for any many to many relationship existing. We will check for the cardinality ratio, that is many to many. First we check for many to many. Okay, is there any many to many relationship? Yes, many to many relationship exists between stores and item. Many to many relationship exists between cities and item. Many to many relationship exists between items and orders. Okay, so what is the rule for rule if many to many occurs? If many to many occurs, what we do is we will create a separate schema for the relationship. For example, for here hold, we will create a separate schema. In that separate schema, we will use the attributes as the primary key of this one and this one, because the hold is actually related with stores and set item. Okay, so when we create a schema hold, the schema hold will be having attributes like the attributes as the primary key of store, which is store ID, and the primary key of item, that is item ID. Okay, so hold, let's check hold. This is hold. In hold I have mentioned store ID, item ID. Clear? Also the hold is having another attribute called quantity held, so that also I have mentioned here. Clear? So store ID, item ID are the foreign keys. So from where I have got this key? I have got this key store ID from store and item ID from item, right? So I will just mark using a directed line. The store ID I have got from here. So this is the marking. Item ID I have got from the schema item. Okay. So you have to mark with the connected lines. So that is all. Next we check the next many-to-many cardinality. Many-to-many cardinality exists between item and orders. Okay, item and orders. What is the relationship? Item order. So I will create a schema for item order. In that, the item ordered schema must contain the primary key of attributes having the primary key of items and orders. What is the primary key of items? That is item ID. What is the primary key of orders? That is order number. Okay, so I just check. Now, items ordered. Items ordered, I have created a separate schema. In that I have mentioned item ID and order number. Clear? This item ordered is also having a attribute called quantity order. Okay, that also I will mention here, quantity order. Clear? Then I will mention from where I have received this item ID. Item ID is a foreign key I have received from this schema item. So I will connect it using this directed line. Order number I have got it from here. Okay, I will just connect it through. So this foreign key is I have received from this one. Okay, so this is the foreign key and this is the primary key. Okay, next another many-to-many cardinality, it exists between cities and item. Cities and item. Okay, many-to-many cardinality. So there I will create a separate schema for in cities. In city schema must contain attributes like city name state and item ID. Okay, so in cities having attributes like city name and state. The city name and state is the primary key of the cities. Okay, primary key of cities, and item ID is the primary key of what? Item ID is the primary key of this one. Okay, item ID is the primary key of this one. So this item ID I have received from the from where? From this item schema. So I have to put a directed line from there. So I have to put a directed line from here to here. Okay, that I have left. Clear? So this is the way. So that is over. Next case. Next, in cities, in city relationship is having another attribute called quantity in cities. That also I have to mention. That also I have mentioned here. Okay, now that is over. Now the leftover is the one-to-many relationship. Is there any one-to-many relationship or many-to-one relationship? Yes, many-to-one relationship is here. One-to-many relationship is here. So here in the question they have mentioned that it is total. The participation is total. So it is total participation. So what we do is, since it is total participation, what we do is we will look at the many side or n side. In the n side, I will include the primary key of the other entity, that is city name and state I will include along with this stores. Clear? That is the rule here. Okay, in the stores, where is the stores? This is the store. The store I have included which all attributes? I have included the primary key of the cities also, that is city name and state. City name and state I have included here. Okay, city name and state I have included here. Okay. Clear? Then I have to show from where I have received the city name and state. That also I have to mark it here. So city name and state I have received from this one. So city name, then also the state. This also I have to mark here. Okay. Next one. Is there any another many to or many here it is many to one to many relationship is exists between customer and order. Okay, since it is total participation, what we do is we will include this customer name also into the ordered in this orders list. Okay, since it is many to one, we will look at the many side. So this many side will be stronger. This many side will be absorbing the keys from the other entity type. Okay, so the orders will have the primary key of the customer also here. Okay, so orders will be order schema will be having 3 attributes: order number, order date, and customer name. Okay, so orders is having three attributes: order number, order date, and customer name. So customer name I have received from this customer. Okay, so this is actually the relational schema for the given ER diagram. Okay, you just follow the basic rule. By following that basic rule, we can very well draw this figure. Okay, this is a essay question. This I think it is a 9-mark question. Clear? Okay. Now we can move to the next topic, that is lecture 4. It is an introduction to structured query language. So today we are going to start with the introduction to structured query language, SQL. So what is SQL? What is the use of an SQL? We have already talked about database. Okay, database, how to create a database, what all operations we can perform on the database. Okay, we can create a user can create a database. He can insert values into the database. If he wish to update the database, he can do. Okay, so many operations a user can do with the database. So how a user is doing these operations with the database? That is done using a structured query language. Okay, the structured query language is actually an interface between a user and the database. Okay, so it is an interface between user and the database. Clear? So before going into the details of structured query language, just go through the history of the SQL. So SQL is actually developed at the IBM lab, and it is developed by Donald D. and Raymond F. in the 1970s. Okay, at that time they have named it as SQL. Okay, not SQL, SQL, Structured English Query Language. Okay, SQL was actually shortened to SQL. Okay, so initially the name was SQL. Clear? Wow, so the main purpose or the main objective of the SQL was to update, store, manipulate, and retrieve data stored in the relational database. Okay, so that is what I have just told you. That is, whatever operations I have to manage in the relational database, I can do it with the SQL. What all operations I can do? I can update the database. I can store new values into the database. I can manipulate values in the database. I can retrieve information from the database. Okay, many such operations can be performed in the using a SQL. Okay, many such operations in which database? Relational database. Why relational? Because only the relational database uses the SQL. Okay, what is relational database? The data stored in the form of tables or relations, that is called a relational database. Okay. So first topic, that is data definition language. Okay, in the module 1 also we have talked about data definition language. Okay, SQL it is having two different languages, data definition language and data manipulation language. So what is the purpose of data definition language? So data definition language is actually creating the structure of the database. For example, we are going to create a user wishes to create a database called student, and the student database must contain the following things: what roll number, name, marks. Okay, so they have planned to create a database. Okay, at the first instance itself, they will not be able to insert the values. Okay, there are certain procedures. First, we have to create the database. For creating the database, we have to mention the what attributes. The attributes are roll number, name, and marks. Okay, that we have to give. Then we also have to give what is the data type of the roll number. Roll number must be of integer type or varchar type. Name must be of character type or varchar. Our marks must be of floating type. Okay, so all those things we have to mention. So before inserting the values, we have to perform a so certain preparations. We have to do certain preparations for storing the database. Okay, that is called the structure of the data. We have to create the structure or the schema of the database or schema of the relation. Okay, so that is what they are saying, that the SQL data definition language allows the specification of information about relations. Okay, specification of the information about the relations. Specification means what is the relation name, what are the attributes, what are the data types. That is called the specifications. Okay, so the specifications include the schema of the relation. Okay, the schema is the what we have seen just before. Schema of the relation. The domain values. What is domain values? Domain values is nothing but the permitted values that is allowed, that is permitted values that can store in the database. For example, we told that in the student database we are having attributes roll number, name, marks. So the permitted value for the roll number is what? Integer values. Only integer values can be permitted. Name, the permitted values in the name is character values. Okay, the permitted value in the mark is floating values. Okay, all those things. Then the integrity constraints. Any rule or any conditions we have to, if we wish to make certain conditions, we can make. For example, the roll number, we wish to make a condition that the roll number must be a primary key. Okay, it can be used uniquely identify a particular attribute. So roll number is a unique key. Okay, so that is a primary key. That is an integrity constraint. Okay. Now domain types in SQL. Domain type, I just mentioned that what are the domain type. Domain is the values, the allowed the permitted values that we can store in the database. Okay, so that is actually mentioned in the data type. That actually tells the data type. Okay, so what are the different data types? Character, char of n. Okay, fixed length character with the user specified length. We can specify the length. If we wish to store a character of length 10, we have to give char of 10. Okay, so this is varchar of n. Varchar means variable length character strings. Okay, this is variable length. This is fixed length. This is variable length. With the user specified maximum length, we can specify the maximum length. Okay, if we specified varchar of 10, then we can store characters up to 10. Okay, 10 in length. 10 characters we can store. Okay, next is integer, then small int. Okay, that all we are familiar with. Real double precision. Okay, that is also available. Then float. Okay, we can also given simply as float or float of n. We can given the precision also we can give. Okay, that is what n. Float of n specifies the precision. The floating point number with the user specified precision of at least n digits. Okay, that also we can specify. So these are the data types or the domain types in SQL. Okay. Now DDL. So today we are going to see about the DDL commands. So data definition language. I have already told that data definition language that is actually used to create a database schema, okay, or define a database schema. Clear? So data definition language actually consists of SQL commands that can be used to define the database schema. Okay, it contains SQL commands to create or define the database schema. It simply deals with the description of the database schema and is used to create and modify the structure of the database objects in the database. Okay, it is having commands that can be used to create and modify the structure. We can modify the structure of the database. Okay, we can create a data structure, also we can modify the structure if we want to. So examples of such DDL commands are shown below: create, drop, alter. Okay, so first we are going to see about the create command, then drop command, then alter command. So create is actually used to create a database. Suppose we want to create a table, we can use the command called create. Okay, it is used to create a database or its objects like table, index, function, views, store, procedures and triggers and so on. Okay, so basically today we are going to see the creation of the table. Okay, index and function we are not going to see today. That is available in the next module. Okay, today we are going to see about the table creation. Okay, then drop. So once the table is created, if we don't want the table anymore, we can we can eliminate that table or delete the table. In order to delete the table, we use the command called drop. Okay, it is used to delete objects from the database. So all the objects related to that table will be deleted, okay, or removed. Alter is we can modify the structure of the database. For example, initially we have created the student table with the 3 attributes: student name, roll number, student name and marks. Later we have decided that we wish to add one more field, that is date of birth. Okay, so that is modification of the structure. Such modification is done using alter command. Okay, now create table. First create table. How we are going to create a table? Okay, this is the way. SQL relation is defined using create table command. So the create table, what is the this is the syntax for the create table. Okay, so create, first we write the keyword create, then space, we will give a space, then write table, then space, we will give the table name. Suppose we want to create the table named student, we will write create table student. Okay, inside the student, what we will write the attributes. I have told that we have 3 attributes: roll number, name and marks. Okay, so inside the bracket we will give A1. So A1 is the first attribute, D1 is the data type of this attribute. For example, if I am wishing to write roll number, okay, so I will write roll number space. What is the data type of the roll number? It is integer, so I will write integer or int. Okay, so first data type is over, comma, then I will put comma. Then second attribute is name. Okay, so A2, that is name, space, the D2 is the data type of this A2. Okay, so name I will write, name space, the data type is varchar. Okay, likewise we can write all the attributes like this. Okay, like this we can write all the attributes. Okay, comma. If we wish to provide any integrity constraint, we can do it. For example, if I wish to consider A1 as the primary key, then I can give the integrity constraint. Okay, so this is the syntax for the create table. Okay, we will see an example. So here R is the name of the relation or name of the table, AI is an attribute, A is an attribute name of the schema of the relation R, and DI is the data type. Okay, so this is an example. Here they are creating a table called instructor. So create table instructor, we will open the bracket, then write the first attribute ID. ID is the first attribute. The ID is of character of length 5. Name is varchar. Name is the next attribute. Its data type is varchar of 20, variable character of length 20. Okay, next department name. Department name is the next attribute. Its data type is varchar. Now salary is the next one. Its data type is numeric 8, 2. Or just we can write integer or 40. Anything can be written. Okay. Now we will discuss how integrity constraints are given in this table. Okay, there are 3 types of integrity constraints: entity integrity constraint, referential integrity constraint, domain integrity constraint. Okay, so entity integrity constraint we have already studied. So entity integrity constraint says that the primary key value, we already set a primary key value, that primary key value must not be null. Okay, we will set a primary key value and that primary key value must not be null. Okay, that is the one. Next is a referential integrity constraint. Referential integrity constraint is the foreign key. Okay, that we already discussed in the last session. Foreign key, primary key mapping. Okay, for a foreign key is a key that refers to the primary key of another entity set. Okay, so we'll be discussing about the those concepts. Then domain constraint. Domain constraint is the data type, integer, float, varchar, all those things we have just discussed. Okay, so these are the integrity constraints you can provide the create table command. So primary key A1 etc. up to AN. So we can specify which all attributes we require to have as the primary key. Okay, suppose we are specifying only the roll number as the primary key, then we just write the primary key roll number, that is enough. Suppose we are going to take roll number as well as name as a primary key, then we have to mention primary key roll number as comma name. Okay, next foreign key. So foreign key, so this is the syntax for creating a primary key. Next for this the syntax for creating the foreign key. The foreign key creation is like this. We will mention foreign space key, open the bracket. So which attributes we wish to have as the foreign key, that we will mention here. Okay, then we close it. Then we will give the references. That foreign key must reference to a entity with a reference to a primary key in another relation, right? That is called foreign key. So we have to give also the reference also, which relation this foreign key is referring, that also we have to give. Okay, so foreign key, set of attributes, references, which relation, S is the which relation the foreign key likes to refer. Okay, so the values of the attributes am etc. up to an for any tuple in the relation must correspond to the value of the primary key attributes of some tuples in the relation S. Okay, so these are the attributes we wish to have as the foreign key, and S is the relation from which we wish to have those attribute as the primary key, those attribute as the foreign key. Okay, this is not null. Okay, next one is not null. We can specify certain attribute as not null. For example, we can say that roll number field must not be kept empty. In that field we can specify it not null. Okay, so let us see certain example. So this is on relation. So these are two relations, department and instructor. Here the department, we are having three attributes: department name, building, budget. Department name, building, budget. Okay, this is another relation, instructor. It is having 4 attributes: ID, name, department name, salary. Okay, so so here we are actually going to create the table instructor. In the instructor they have given an arrow from department name to department name. From here department name is connected to this one, which means that here department name is the foreign key. Okay, this department name is the foreign key, which is referring to the primary key of the department table. Okay, so here department name is a foreign key. This foreign key is referring to the department name, which is the primary key of the relation department. Okay, so how can we give this constraint? Okay, so this is the way. So create table instructor. Okay, so instructor, I am going to create this table, not this table, this table. This table is already created. Okay, this table I am going to create. So instructor, the first one is ID, the data type is character, I have given it as character. Okay, name I have given as just varchar. Okay, and this name field, I am saying that this name field should not be let kept empty. So that is why I have given not null. Okay, so this is the format. So create table instructor open bracket, then I will write id, the name of the attribute, space, what, single space is enough. Okay, single space character. Okay, that is over. So comma, the next attribute name, the data type is varchar of 20. Okay, so along with that I am specifying that this must not be kept empty, that is not null. So I will just give a space varchar of 20 space not null. Okay, so the constraint for the name is over. So comma, next department name is varchar of 20. Okay, now salary is numeric, salary is integer or numeric or floating, anything. Okay, now we have to set the id. Here the primary key is id, it is underlined from here, from the table itself, from the schema itself it is understood, that is id is underlined. So primary key is id. So I will set primary key bracket id. Okay, so here the primary key is id, so primary key inside bracket I will write id. Okay, not over. I also need to specify the foreign key. Okay, primary key I have specified. What is the foreign key? Foreign key is department name. So foreign key, next one is, so primary key id comma foreign key department name. Okay, this is referring to which table? This is referring to the department table. So foreign key department name, the attribute name. Okay, that is the foreign key. References, okay, space references, where which table? Department. Okay, this is the syntax. Okay, this is an example. So foreign key, the name of the foreign key, referring to which one? Referring to which table? References, department. Okay, clear? Then we will close the main bracket and put the semicolon. So each SQL statements must be terminated by a semicolon, that is the rule. Okay, this is the create table syntax. Okay, so while running this statement, this table will be created. Okay, table with the following constraint will be created. Okay, next another example. We are going to create a student table. Here the student table id is the primary key and department name is the foreign key. Okay, so create table student id varchar of 5, name varchar of 20. So name must not be kept empty. So name against the name I have written varchar of 20 space not null. Okay, so the constraint is over, comma. Next one is department name varchar total credit numeric or integer, anything. Okay, so next I am going to write the constraint. Okay, so total credit, that is over. So 3 attributes and this constraint I have mentioned. Next I am going to mention about the primary key as well as the foreign key. Okay, so I just put the comma, then primary key I will mention. Primary key, which one? Primary key open bracket, that name of the attribute which I wish to have as the primary key will be written here. Okay, so id is the primary key, I will close it, comma. Next I will mention about the foreign key. Foreign key is department name. Okay, so foreign key department name in the bracket. Okay, which is referring to which table? Which is referring to department table. So references department. Okay, I close the bracket, semicolon. By executing this statement, this table will be created. Okay, similarly another one. Similarly another table. Okay, here we are going to create this table. In this table we are having one primary key and many foreign keys. Okay, not one primary key. We are having 1, 2, 3, 4, 5 primary key. Also foreign key also. Okay, so here I will write id varchar course id. So all these attributes I will mention here. Then primary key is id comma course id comma section id comma semester comma year. Okay, why? Because all these things are primary key, because all these things are underlined, so these are primary key. Okay, this is also foreign key. This is primary key as well as foreign key. Why? Because this id is referring to which id? the ID of the student. This course ID, section ID, semester, year, it is pointing to the corresponding attributes in the table section. Clear? So foreign key is the ID which is referring to student. Foreign key, all these foreign key, course ID, section ID, semester, year, all these things are referring to which table? Section, references section. Okay, close the bracket, semicolon. So this is the syntax for the create table. This is another one. This is another one. Okay, here going to create the course table. In the course table I am going to have course ID, title, department, credit. Course ID, title, department, credit. Okay, in this I am giving the primary key as the course ID. So primary key, course ID. Then foreign key is department name, which is referring to department. So foreign key, department name, references, department. Okay, so this is an example for the create table command. Okay, next one is drop table. How we can drop the table? Drop means eliminate the complete table. All the structure of the table will be eliminated. So drop is used to delete the whole database or just a table. The drop statement destroys the object like existing database, table, index, view, anything. Okay, everything. So when we perform a drop table command, all the things associated with that table will be completely removed. Okay, so a drop statement removes the components from the relational database management system. Okay, all the components related to that table will be removed. Okay, so what is the syntax for the drop table? Drop object name, or drop table name. If you want to create it, if you want to remove a table called student, then the command will be drop table space table name. Okay, so table name is the name of the table to be deleted or removed. Okay, so this is the command for dropping or removing the table. Drop table name. Okay, next is alter table. Okay, one more SQL command, one more DDL command is there, which is alter command. Okay, what is alter command? So alter means, alter command is actually used to modify the structure of the table. Okay, suppose we are already having a table, roll number, a table of student having roll number and name, and we wish to add, so this is the existing table, we already stored the values. Now we wish to add two more columns. So two more columns addition means we are actually modifying the structure of the table. Okay, initially the structure had only two attributes, so now we are adding two more columns. That means we are adding two more columns to the structure. Okay, so alter table. So I will just I am adding two more columns like age and course. Okay, so I can write the command like this, alter table. So the SQL command is like this, alter table. I am altering which table? The table name is student. So alter table student. Okay, so alter table student. I am going to add which all attributes? Age and course. Okay, so alter table student, alter table name. Then I will mention add. That I will use the keyword add. Okay, then I will open the bracket. Which all column I wish to add, or which all attribute I wish to add, that will be given inside this bracket. Okay, so I wish to add age. I wish to add. Okay, so when I am adding age, I also must include the data type. The age must have the data type number. Okay, number or integer or anything. Okay, next, so that is over. I am going to have created age, then comma. Next attribute is course. What is the data type of the course? Varchar. So course space varchar of 40. Okay, varchar of 40. That varchar of 40 must be written in the bracket. Okay, then we will close this bracket. Okay, close this bracket for the this add command. Okay, clear? So this is the way we will be creating. So this is how we will create we'll alter the column. Okay, we have here we have added, additionally we have added 2 columns. Okay, so alter table drop. Next we will drop 2 columns. Here we have additionally added 2 columns. Next we will drop 2 columns. Okay, what is the syntax? Alter table drop. Drop a column is used to drop column in a table. Okay, so we are having a command called drop column. Using the table drop, using the command drop column, we can remove columns in the table. Okay, deleting the unwanted columns from the table. So the syntax is alter table name. Okay, alter table name, alter table the table name. Then we will write drop column space the column name, which column we wish to drop, that is written here. Okay, I will repeat it again. Alter table is a keyword, then you will mention the table name. For example, alter table student. Okay, drop column the column name, for example age or marks, anything. Okay, so this is the syntax. Clear? Now alter table modify. Suppose we wish to have an existing column to have another data type. For example, here we have created additionally we have created 2 column called course. In the course we have mentioned the varchar as 40. We have course, we have mentioned the data type as varchar of 40. Okay, so we wish to have the varchar as data type as varchar of 20 instead of varchar of 40. Okay, so that's much memory we don't require. So we wish to modify the data type of the course as varchar of 20 instead of varchar of 40. So in that case, what can we do? We can just use the command modify in the alter table. Okay, so alter table modify, it is used to modify the existing column in a table. Multiple columns can also be modified. Okay, we are actually modifying an existing column. Multiple columns can also be modified. Okay, what is the syntax? Alter table, the same alter table command, alter table name. Okay, modify column name, column type. Okay, as I have just mentioned that I am going to modify which column? Course column. Okay, so I will just write the command like this: alter table, the table name is students. Okay, I am going to modify. Okay, now I am not going to add or drop, I am going to modify which column I am going to modify? Course column. Modify course. Okay, in course column, what modification I am going to make? I am going to make the data type from varchar of 40 to varchar of 20. So I have made it as varchar of 20. Okay, clear? So this is how we will use the alter command for add, drop and modify column. Okay, so alter command actually is a DDL command that can be used to modify the structure of the relation or structure of the table. Okay, so this is the DDL command that we have studied today. Okay, today we are just discussing about the DDL commands. In the next session we will be discussing the DML commands. Okay, so we have just covered the DDL commands: create command, drop command and alter command. Okay, so in the next session we can cover the DML commands. Okay, thank you.